Welcome to the beginning of Chapter 2. Chapter 2 is going to be all about functions. So in this first lesson, we're going to just talk about the difference between relations and functions, how to identify functions, and how to evaluate them. Okay, so those are the two things that I want you to walk away from this video with. So to begin, let's talk about all the vocabulary that you're going to need to know. Okay, this first lesson has a lot of vocab. So everything we talk about today is going to be relations, okay? Relating X and Y together. So what is a relation? Well, a relation is a pair of inputs and outputs. Okay, so, and I know you've heard the terminology before, but again, I just want to review it with you so you're very clear when I use this language. So inputs are going to be the domain or the X values, okay? So domain is connected with X, while outputs are your Y values. And the collection of Y values we are going to call the range of the relation. So we're going to come back to those a little bit more on the next slide. But now let's talk about how can we represent relations, okay? There's four main ways we can represent these, okay? I could list them as ordered pairs or as points. I could make a mapping. I can make a table, or I could graph them. Okay, so again, those are the four main ways that we are going to discuss representing relations. Now let's get back to this idea of domain and range, okay? So we're going to start with domain and range of discrete points, so kind of like what we were just looking at, where I have a list of points. All right, so when you have distinct points and you're asked to find the domain and range, you can simply list the specific X values as a domain and the specific Y values as the range, okay? So let's take a look at what I mean. So we have an example. When skydivers jump out of an airplane, they experience free fall. At 0 seconds, the skydiver is 10,000 feet above the ground. So we're going to say that's where the skydiver is starting from, okay? After 4 seconds, he's at 9,744 feet. Then at 8 seconds, it's at 8,979. And at 12 seconds, he is at 7,696 feet. Finally, 16 seconds, he is at 5,904 feet. So this is a relation. We're comparing how many seconds have passed, and we're relating that to how high the skydiver is off the ground. So here I've shown you the four ways that we can represent this, okay? As a mapping, as ordered pairs, as a table of values, and then graphically, so kind of as a scatter plot, which we'll come back to those more later in this chapter. So right now, let's just focus on this idea of domain and range, okay? So domain, if I'm going to list the elements in my domain, remember these are distinct values, okay? We only tracked at particular points. So my domain is when I'm just going to list those inputs, or you can think of it as listing the X values of the ordered pairs. Okay, so my domain is going to be 0, 4, 8, 12, and 16. The range is going to be the list of Y values or the list of outputs. Okay, so listing outputs, or think of it as listing the Y values of the coordinates. Okay, so when we look at that, the range is going to be, well, I have 5,904, 7,696, 8,976, 9,744, and 10,000. So when it's distinct points, you can literally just list them out. Let's say you're looking at the graph, okay? So for the graph, so here we have one at 0, 0, or I'm sorry, not at 0, 0. The point was up here. So 0, 4, 8, 12, 16. So that's how you do it for a scatter plot. You would just kind of scan over to see where are they lining up with my X's, where are the points lining up with my Y's. Okay, and that's how you would track it graphically. So Now let's take a look. So now that we have an idea how to do it with discrete values, just listing those particular values, let's talk about what about continuous graphs, okay? Because this is what we deal with more often, okay? Continuous graphs, whether it be a line, a parabola, hyperbola, all of those things. So you're going to use inequalities to represent the domain and range. So for example, your domain might be x values that are less than 3. Your range might be y values that are greater or equal to 0. So we're going to be using inequality statements when we're talking about continuous graphs. Okay? Now, one little hint I have for you. That hint is when you're looking at these graphs, look if there's any unique points, okay? Look to see if there's any points that create kind of a minimum or a maximum, okay? And I'll get back to that idea in just a second when we get to the graphs, but that's going to be one of the keys. Look for those kind of unique points that are creating boundaries for your graph. If the graph continues on in both directions forever, this means that x or y can take on any value. You're going to want to label that as all real numbers. Okay, so for example, if we look at this first one at the line, so if you look, when we're trying to label our domain, again, domain, we're looking at x values. Well, if we're looking at this, x values are horizontal, okay? So if we look, this is going to keep going towards the right forever, and it's going to keep going towards the left forever, okay? It's spanning out in both directions forever, left and right. So that's going to be one of those all real numbers situations, okay? I can use any x value. All x's are part of this line. And what about range? Range are the y values yet again, but if you're looking at this line again, think about this. This is going up forever, and then this is going to keep going down forever. So for the y values, it's also spanning up and down forever. It's going to encompass every single y value. Okay? So the y as well is going to be all real numbers. Any y value is going to appear somewhere on this line. So that's what it looks like to be all real numbers. Now let's look at where there's some constrictions on them, okay? So let's focus on this second one now. Let's move on to this. So domain, again domain, we're talking about x values. I want you to look at this. So this, if I continue it, is going to go on right forever. This is going to continue on going leftward forever. So once again, we have the situation. It's going right forever and it's going left forever. So that's going to encompass every single x value. When it encompasses every single value, we're going to call that all real numbers. Now what about the range? The range is going to be a little bit more interesting this time. So range is going to be y values. Now there's something I want you to notice, okay? Notice this point right here, okay? So when I said look for unique points, that's one of the things that I was talking about. That point right there, notice you never go beneath it, okay? So you never go below that value of -4. However, if you look at your graph, you're going to go up forever, up forever. You just never drop below that -4. Okay, so what is that telling us about our range? Well, what it's telling me is every y value that I'm going to use, every y value has to be greater than or equal to that value of -4. Okay, so that's why I want you finding those unique points, because that's going to give you the boundary for your inequality. In this case, your y's start at -4 and they just go upward forever from there. So every y value that you use is going to be greater than or equal to that -4, that point right there. let's look at this one, okay, that ellipse. So here, now we have multiple special points, okay? So when I look at the domain, which again is my x values, when I look at that, I see two special points right here. Okay, so it looks like all my x values are squished in between those points, okay, in between there, in between there. It never goes beyond those 2 points, okay? Nothing goes to the right, nothing goes to the left. So all of my x values are scrunched in between that -6 and +6. So this time my x is bounded in both directions, okay? It's never going to be above 6, never going to be below -6. And what about my range? What about my y values? Well, again, look for any points that kind of squish it from going up or down. Well, I see this is my highest point for y, and that is my lowest point. And notice everything, all my y's, are scrunched in between. You'll never go above the 2, you'll never go below the -2. So again, this is going to create an inequality. The only y's that are possible for this graph are equal to or greater than -2 or less than or equal to +2. You're squished in between there. Again, my biggest piece of advice, find those unique points as you're looking for these. Which ones kind of create those boundaries that you never see go left or right from or up and down from. Oh, now, the next idea we're going to talk about is being a function, okay? So we've talked about domain and range. Now we have to talk about what does it mean to actually be a function. So a function is a relation where each element in the domain's x corresponds to each element in the range or the y's, okay? So every x can only go to a single y. Now, what does this mean? Well, in mappings, it means that the function cannot have an input going to different outputs. Okay, so here, this would be a function, okay? Because 2 is going to a single output. 4 is going to a single output. 5 is going to, or sorry, -5 is going to a single output. So that works. Each x is only going to a single y value. It's okay if they go to the same y value. So notice these two are both going to -1. That's fine. All that matters is that each x is going to only one y value. This one is also a function. X, or sorry, 8 goes to 6, 1 goes to -7, -4 goes to -9. That one also works. That is a function. So where does it fall apart? Because this one is not a function. Why is this falling apart here? Well, the problem is right here. You have 1 going to -7 and to -9. That's what you can't have. Every x can only go to one y value, no more than that. So that branching out from the input, that's what is going to be the red flag that that cannot be a function. What about for a list of points? All right, well, this means that each point should have a different x value. So what that means, no repeats, okay? If x repeats in that list, that is a problem, okay? So let's look at this first one. 4, -1, 8, 6, 1, -1, 6, 6, 4, 1. I see a problem here. I see the x value of 4 going to two different values. It's going to 1 and it's going to -1. So that's why I say in a list of ordered pairs, x should not repeat because that's going to make this not a function. It's showing 4 going to two different y values, and that is not okay. In the second one, so now focusing on this one, so -7, 14, 9, -7, 14, 7, 7, 4. So notice all of these x values are distinct. All those x values are different, so each of them is going to their own y value, to a single y value, so that will end up being a function. All right, and then lastly, for graphs, we can use what's called the vertical line test. Okay, so this is going to be the last piece of determining if something is a function or not. So, for the vertical line test, if you can draw a vertical line that touches the graph or points in more than one location, so more than once, it fails and is not a function. Okay, so for example, on this one right here, I can draw a vertical line and it touches 2 points. Okay, that means that that x value has 2 different y values that it's going to, therefore not a function. It fails the test if it touches more than once. This one, notice, no matter where I draw a vertical line, it ever only touches a graph one at a time, okay? Each vertical line only touches once. So this passes the vertical line test. This is going to be a function. Each x is only having a single y value. Here, if I draw vertical lines, notice no matter where I put them, it's only touching each point once. Okay, so this is also going to be a function. Then this one, when I draw my vertical line here, it's touching twice. So again, this is that red flag that comes up. This one is failing our test. This one is not a function. Okay, so do make sure on this page, each of these rules, make sure you're very clear on the ways to determine is something a function, is something not a function. But it all comes back to that same idea. Every x value can only go to a single y value. Okay, that's the overarching idea of this section. Now, lastly, let's talk about function notation. Okay, so looking at this, function notation is literally just using f of x instead of y, okay? And it reads f of x, so basically f of x is literally just a fancy way of writing y, except it comes in handy, okay? It's useful to us because we can say, all right, well, if this is my function f of x, f of 2 literally just means plugging 2 in for x, okay? That's literally all it means to do. So it makes evaluating easier. If I give you the function, so here you know what f of x is, well, if I tell you find f of 2, well now you know, without me having to write out a ton of words, you know, oh, plug 2 into that function. 3 times 2 is 6, plus 2, so f of 2 equals 8, okay? So what that's telling you is the point 2, 8 is part of your graph. 2 is the x coordinate, 8 is the y coordinate for that graph. Okay, so that's really all it's telling you to do. So let's get a little bit of practice in for that. So here g of x is x squared plus 5x minus 3. So if I want to evaluate for -1, again, I put -1 in everywhere I see x. Okay, I'm just substituting it in. So here I get 1 minus 5 minus 3, and so that's giving me a -7. So g of -1 is -7. And what that's telling me is for the g function, the point -1, -7 is on the graph, okay? That is part of that graph. What about h of -7? So h of x is the absolute value of x plus 1 minus 5. So let's plug in -7. So here, absolute value of -6 minus 5. Well, absolute value -6, we'll just make it positive. So we have 6 minus 5, which is going to be 1. So again, let's think, what is that telling me? It's telling me the point -7, 1 is on that graph. The x value is that -7 we were plugging in. That's our input. The output we're getting is 1. All right, so we can also apply this notation when we're looking graphically. Okay, that's going to be another skill that I want you to be pretty affluent in. So if I ask you, what is f of 0? Okay, so basically that's telling you x is 0 and you want what y equals, okay? So this is an example of them giving you x because they're telling you f of 0 and they want the y value. So here's x of 0. Where is y? Well, the function is right here. Okay, so y is going to be 1 when x is 0. Okay, so you can do the same thing graphically. And again, it's just telling you the point 0, 1 is on the graph. Okay, now what about the other way? What is the x value when f of x is -1? So now this is the reverse, right? So this time, again, f of x is just fancy y. So here, you know y is -1, and it's asking you for x. You want the x value when y is -1. Okay, so let's take a look at that. So y of -1 is here. So the graph, that's where the graph is, okay? That's where the graph is when y is -1, and that it wants the x value. Well, the x value is going to be -2. All right, so here when we're looking at this, this is telling us we have an x value of -2, y value of -1. So there is another point on the graph. But just know what they're giving you and know what they want from you when they're using this notation. Okay, so a lot of really good stuff to take in from these notes, a lot of vocabulary. So what I'd like you to do is, can you please take a moment here, write that summary for me, okay? Take a few moments, just write down some of the key things, maybe something you want to remember, some tricks you picked up from this video. Just summarize what you learned and then come back ready to do your practice work.